Welcome. If you're an MEP student, a junior engineer, or out there on a site team, you know that designing a hot water system can feel like a huge puzzle. But guess what? It doesn't have to be. In this explainer, we are going to break down exactly how to design a complete, code-compliant hot water system right from scratch. That's the million-dollar question, right? And the answer isn't some secret formula. It all comes down to a clear, systematic process that makes sure you get every single detail right, from that very first calculation all the way to the final blueprint. Okay, so here's our game plan. We're going to walk through this journey together, building our system logically, piece by piece. We'll start with the challenge, then get into the nitty-gritty of demand, picking the right gear, sizing the pipes, and of course, the all-important recirculation loop before we see how it all comes together. To keep this from being all theory, we're going to get our hands dirty with a real-world example. We're designing the entire hot water system for a modern family villa. It's a super common project, and the principles we cover here, you can apply them pretty much anywhere. Here we go. And listen up, because this is probably the most important part of the entire design. Seriously, if you get this wrong, everything that follows is built on a shaky foundation. Our first, most critical step is to figure out the absolute maximum amount of hot water the system will ever need to provide at any one time. We call this our peak demand. Now, you might think this is some crazy complex math, but the building codes actually make it pretty straightforward. It really just boils down to these three simple steps. We list every single fixture, we add up their fixture units, and we'll talk about what that means in a second, and then we convert that total into a flow rate. It's a really logical process that takes all the guesswork out of it. So what in the world are these fixture units, or FUs? The easiest way to think about them is like a point system for water use. The International Plumbing Code and the Saudi Building Code give each fixture a score based on its demand. So a simple bathroom sink, a lavatory, that's just 1 point, or 1 FU. But a big clothes washer that really guzzles hot water, that gets a much higher score, 4 FU. Makes perfect sense, right? So for our villa, we literally go through the plans, find every shower, every sink, the kitchen, the washer, and just add up the points. For this project, our grand total comes to a nice clean 10 fixture units. That's our starting number. Okay, so here's where the magic happens. We've got this abstract number, 10 FU. This is the crucial step. We turn that number into something real we can design around. Using standard conversion charts from the plumbing code, that 10 FU translates to a peak demand of roughly 22 liters per minute. That's our design target. That's the flow rate our system has to deliver, no sweat. Awesome. Now that we know exactly how much hot water we need, we can choose the heart of our system, the water heater. And because we did our homework on the demand, we can pick one with confidence, knowing it's a perfect match. First, you gotta decide on the type. Are we going electric, gas, solar? That depends on things like what utilities are available. Then we size it. The codes give us solid guidelines, and for a villa like ours, something in the 200 to 250 liter range is the Goldilocks zone. It's big enough for the peak load, but not so oversized that it's just wasting energy. So for our design, we're gonna lock in a 250 liter electric heater. All right, we've got the heart. Now it's time to build the arteries, the network of pipes that will deliver that hot water efficiently to every single tap. This is where we go from thinking about a single component to designing the system as a whole. Pipe sizing is more of an art than you might think. It's not just about making them big enough. It's a delicate balancing act between the flow rate and how fast the water is moving. Get it wrong, and you're in for a world of problems. Get it right, and the system just works. So check this out. If your pipe is too skinny for the amount of water you're pushing through it, the water velocity just skyrockets. That's what causes that annoying whistling noise you sometimes hear in walls. But worse than that, it's literally like sandblasting the inside of your pipes over time, causing them to erode and fail prematurely. Our goal, the sweet spot, according to the code, is to keep that velocity between 0.6 and 1.0 meters per second. That gives you a quiet, efficient, and long-lasting system. So how do we hit that target? Well, here's a great rule of thumb for most residential projects. You just look at the flow rate we already calculated. Since our villa's in that 15 to 25 liters per minute range, a 1-inch main line is the perfect choice to keep that velocity right where we want it. Ah, yes, a fantastic question. We've all been there, right? You turn on the shower and you just wait and wait, shivering, while all that cold water that was just sitting in the pipes has to run out first. This question right here, this leads us to the pro-level step that separates a good system from a great one. The solution to that long, cold wait is a recirculation loop. Instead of letting hot water just sit in the pipes and cool down, we create a dedicated return line that brings it back to the heater. This keeps the entire circuit primed with hot water all the time. Now, a properly designed loop, following standards from the SBC and ASHRAE, keeps that hot water constantly but slowly moving. We use a small pump to maintain the flow, and we aim for a return temperature of about 49 degrees Celsius. This means that the moment someone opens a tap, hot water is there almost instantly. For a villa, a 3/4-inch pipe for the return line is usually perfect for the job. So, after going through this whole process, what have we got? Let's zoom out and look at the final specifications, the complete blueprint for our villa's hot water system. And here it is, our complete design summary. We started with 10 fixture units, and that one number led us to a 250-liter heater and a W20 main pipe. We added our 3/4-inch recirculation loop with a correctly sized pump, and we've set our temperature controls for both safety and efficiency. This is a blueprint that's ready for implementation. And A, for all you engineers watching, go ahead and grab a screenshot of this one. This is your toolkit. These are the essential formulas behind the calculations we've been talking about, from figuring out heating power in kilowatts to the specific equations for pipe diameter and pump head. This is a practical toolkit you can use on all your future projects. And that really gets to the heart of what we've done here. This whole process, it's not just about reacting to a need for hot water. It's about designing a proactive, robust system that ensures comfort and efficiency from day one, preventing those problems like noise and long wait times before they can even start. So this leaves us with one last thought. We've built a solid, code-compliant foundation. But the next step is always innovation. So what would you add? A smart, on-demand recirculation pump? Timers? Advanced temperature sensors? How can we take this solid foundation and make it even smarter? That's the next chapter in great engineering design.